Today's lesson is subtracting with integer chips. You do need to know that a yellow integer chip is a positive 1, a red integer chip is a negative 1, and when we have the sum of a positive 1 and a negative 1, it equals 0 because they are additive inverses, and so we can add 0 pairs to any number and not change the value of that number. I want you to remember, try to visualize what you have heard said, that subtracting is actually adding the opposite. We're going to visualize or represent this using integer chips. But first, let's look at a number line to make sure that we see it there as well. We start with a 2, and if we want to subtract 3, that means to go in the opposite direction of 3, and we know that 2 minus 3 is going to be less than 2, so we're going to go in the opposite direction. There's 1, 2, 3, and our answer will be a negative 1. So we are moving, we're taking away a positive 3, so we're moving in the opposite direction. Now let's show that using integer chips. This is an easy subtraction problem that you've done in lower grades. A positive 7 and subtract a positive 4. So subtract means take away. We're going to take away these positive 4s and we are left with a positive 3. This problem is a little bit different because it involves negatives, and we are going to start with a negative 2. As you can see, it's negative 2, and we're taking away a positive 5, subtracting a positive 5, but we don't have positive 5, so we're going to add 0 pairs so that we have positive numbers that we can take away. So there's my first 0 pair, and my second one, 3, 4, and 5. Okay, at this point I have not changed the sum of negative 2 because this entire thing is equal to 0, so I still have a negative 2. Now I want to take away a positive 5 from this negative 2, so I can do that now. So I'll remove these positive 5, and I am left with a negative 2 and a negative 5, which is equal to a negative 7. And now you can see how we could be thinking of subtraction as adding, let me use a different color, adding an opposite. The opposite of a positive 5 is a negative 5, so we've just added a negative 5 to get our answer of negative 7. In this problem, we're going to start with a negative 3. And we want to take away a positive 2. Once again, we don't have any positive values to take away. So I'm going to add 0 pairs so that I have 2 positive ones that I can remove. So a negative 3 plus 0 is still a negative 3, but I can now take away, let me slide that down, take away a positive 2, so I will remove these positive 2s, and I have as my, what was this 0 doing there? I don't know, part of my mistake there. We changed the problem. So I have negative 3 minus a positive 2 is equal to a negative 5, and that would be correct because it would be the same as saying if you are adding the opposite, it would be a negative 3 plus a negative 2 is negative 5. Now let's look at this one. We start with a positive 3, and we want to take away a negative 2. Once again, we don't have a negative 2 in that problem to take away, so we're going to add 0 pairs. I'm going to add 2 0 pairs so that I have 2 negative 2s. Or 2 negative chips rather. Okay, now I have my positive 3. I can remove a negative 2. I'm going to add these together. So it's going to be adding a negative. And my answer is a positive 5. So I added the opposite. Let's use this and go back, if I can find my slide, to a number line and see if that plays out in the same manner. The bottom problem here, we start with a positive 3. Now, if I think about this as I want to take away a negative 2, so I'm going to actually go in the opposite direction of negative 2. Instead of going this way, I'm now going to go in the opposite direction. The opposite direction of negative 2 is positive 2. And I would land on 5. And so you're going the opposite way on the number line, and you are adding the opposite with chips. That's your lesson in subtracting and visually representing adding the opposite. Thanks for watching.